Hey everybody, welcome to A.R.E. Live. I'm Mark Tier, the founder of Black Spectacles, and today's episode features Mike Newman, who's going to review the Site Planning and Design exam. Mike is going to discuss both the grading and the site design vignettes, and he'll talk about the general principles that should drive your solutions, as well as using those principles to suggest the types of questions you're sure to see in the exam. Before we get started, if you'd like to attend our next A.R.E. Live broadcast, visit blackspectacles.com/podcast to register. During the broadcast, you'll have a chance to ask questions and share your answers with Mike. And if you don't know Mike, he's an adjunct professor at the School of the Art Institute of Chicago. He's also the founder of Shed Studio, and he is the instructor for Black Spectacles online AIA ARE Prep Curriculum. If you haven't already checked out our AIA ARE Prep Curriculum, head over to blackspectacles.com to watch any of the free tutorials from the courses. And today we have two very special Black Spectacles promo codes to share, so make sure you stick around until the end of today's episode. But first, let's hand it over to Mike.
So there are two vignettes that are associated with the site planning exam. One is on grading, and one is an actual site design. When I've talked to folks at NCARB, so first of all, big picture, when ARE 5.0 comes in a year and a half or so, they're actually getting rid of all the vignettes. And in many ways, that's a great thing because the vignettes are, frankly, a little crazy. But as I often say, the devil you know, like who knows what 5.0 will be like. I wouldn't wait until the vignettes are gone. I would say dive in now and take it now, because while they're crazy, they're sort of a crazy you can figure out. But not only that, but at various points along the way, I've heard people talk about how the grading vignette and possibly the site zoning vignette might have been removed anyway. But as far as I know, they're both still in there, and so they're kind of smaller ones. The site planning vignette is actually a kind of trickier one that trips people up quite a bit. People tell me that the reason that you might fail on the site grading exam, the site grading vignette, is just because you were moving fast and not paying attention because you're thinking about the other one. This is one you should not fail. Yet people fail it all the time because it's just sort of goofy. And if you don't spend a lot of time doing topography, it's just sort of an unusual thing to think about. So some just quick discussions about kind of what we're talking about here. When we talk about the grading vignette, the issues that we're really referring to, by far the biggest issue here is water drainage. So the whole thing is really about how does water, when it rains down onto the site, where does it go, and does it go into something that we don't want it at? That's essentially the entire point of this vignette. So you're trying to control water as it moves across the site, and then you're going to gather it in some way and move it around the things that you don't want the water to go into, which is generally any structure, often it's pathways or driveways, things like that. There's a few other issues that it could be about. It could have an issue of accessibility, or even just sort of like a slope on a driveway, something like that you would have to check to make sure that a path was actually an accessible path, and we'll talk about that in a second. Another kind of odd but quite real issue here is don't mess anything up. So that sounds a little funny, but what I'm saying there is, if you look on this example over here, there's a bunch of trees. There's like rock formations. There's, in this particular version, there's it's like a sculpture thing or something. I forget what it is. It's like a place for a gazebo or a sculpture or a garage or overlook or something. There'll be something that's part of the site, and you can't change anything at that point. So if like for example in the trees, you can't change the topography in the tree because you'll be changing the roots, and if you change the roots, you're going to kill the trees. So when I say don't mess anything up, what that's really referring to is just don't make the dramatic changes you need to on the site in order to move the water around, but make sure those are contained and tight so that they don't bother anything else. They don't hit the rocks, they don't hit the trees, they don't hit the sculpture. They don't, whatever it happens to be. So that's kind of a key thing, but it's really all about the water. So, and to talk about this, one of the things we have to talk about is the idea of slope, and the sort of rather odd situation that slope is actually referred to in percent. I personally can't stand I think the idea of using the percent term for slope. I think it's very confusing for people, and I find it it throws people off all the time. And there's a very simple reason for this. So when you use percent for a slope, let's say you're talking about a 20% slope. What that's referring to is every 100 feet horizontal is going to be 20 feet vertical. So if you start kind of doing the math, that would mean that for every 1 foot vertical is 5 feet horizontal, right? So it's the same ratio. It's a way of thinking of it as a ratio, so the percent. The reason I don't like using percent as a way of talking about slope is that if we start thinking of like 100% slope, like think in your head, what is 100% slope like? 100% slope sure sounds to me like it's a vertical line, right? That makes logical sense, yeah? Well, but it's not, right? 100% slope is 100 feet horizontal compared to 100 feet vertical. So that's actually a 45-degree line. That's not a vertical line at all, right? So you think about that, let's say that's 100 feet horizontal, that's 100 feet vertical. That, drawn badly, is 100% slope. So you can very easily have a situation where you have 120% slopes or 140% slopes. They'd be very, very steep. It's not likely it's going to show up on the exam, but out in the world, you can actually have that fairly simply, which just sort of is a non-compute in my mind. Like 100%, that should be the top. So that's one of the things to watch out for. You should have a couple of numbers sort of reasonably kind of understood. Those would be 2% slopes, 5% slopes, 20% slopes, 8% slopes. The 8% because that's an accessible slope. And so anything steeper than 8.3% is not accessible. Anything less than that is accessible. If you do the calculation, you realize that a 1 to 12 is going to equal about 8% slope. That's the accessible ramp. So the reason those other numbers come is because those are numbers that are likely to show up on the vignette. 2% slope is the general minimum that you're allowed to have anything slope. So I'm going to move on to the next page here. When we talk about that, that sounds sort of funny. Like, what do I mean by that 2% is the minimum slope? Like, what, you can't have flat? Like, why not? Well, it turns out you actually can't have flat. All those times when we draw something flat on the exterior, it's wrong. There is never anything flat. And the reason for that is water has to go somewhere, and we want to tell it where to go. You don't want to just sort of let the water figure out where it's going to go. You want to tell it where it's going to go. There are a couple of exceptions. You're using permeable concrete or something like that. You can do it with flat, and then the water will actually permeate straight through. There's a few sort of minimal exceptions, but generally you always are sloping the land somewhere. And so you want to make sure that it's going to the place that you mean for it to go. So what they're saying on the exam, typically, they can use a different number, but typically the sort of minimum it can be is a 2% slope. Otherwise, what you're going to get is ponding, and it's going to create all kinds of problems. So if you think about 2% slope, how far apart are the contour lines? Any guesses? The answer is going to be 50 feet apart, because 50 feet apart with a 1 foot contour, 1 to 50 is going to be the same as 2 to 100, which would be 2%. So that will be something that will show up. You'll want to check to make sure that you don't have contour lines that are farther apart than 50 feet, because that'll be too low a slope, and water will pond. 20% is often the sort of maximum that you're allowed to have for certain kinds of landscaping, or for people to be able to wander up and down easily. You start getting over 20%, people start tripping. 50% slope is often the maximum for stopping erosion and some other issues like that. So you'll see a few of these numbers over and over again, and you should just get used to how you use them. One of the things when we talk about topography and doing cutting in swales and making berms and putting foundations in and everything is out in the world, you hear people talk about the idea of cut and fill. And the basic premise here is that you should always balance cut and fill, meaning that if I'm going to take a big bunch of material out of my site, instead of putting it into trucks and trucking it somewhere, I should have figured out where it can go on the site so that I can always balance this out, and I don't have to truck very expensive trucks to move a lot of soil around. One of the things you'll be shocked by is how you see those giant dump trucks, this tiny amount of soil in those things, putting sand or gravel or anything like that. It takes 20 of those, 30 of those, 100 of those before you have any real amount of soil or gravel or whatever it is you're moving. It's very, very expensive. The scale of the stuff when you're outside is just much bigger than it sort of naturally seems. And so having 30 or 100 trucks moving in and out of your site is just very, very expensive. So you're always trying to balance cut and fill. You always try to, if you're going to take soil out, you try to find a place on the site that you can use it. Intriguingly, even though this is sort of a bedrock aspect to how you do grading design, it doesn't show up at all on the grading vignette. So now that I've just said it, totally forget it. You don't have to balance cut and fill at all. Nobody cares. It might show up as a question on a multiple choice question, but it's not going to be part of the grading exam. So let's talk about swales. Swales are essentially ditches, right? A ditch, a swale, is how we're going to corral water to go where we want it to go. And this is one of those things, this is sort of going to seem very sort of simplistic and obvious, but you would not believe the number of times very smart people talk to me about the mistakes they made on this, and it's almost always this issue. So I'm just going to run through it super fast here. So if you imagine we have a little cutout of a slope of land, and if each of these lines is sort of representing let's say a 1 foot contour, like a 1 foot elevation level difference. And by the way, the contours don't have to be 1 foot apart. They could be 2 foot, they could be 5 foot, they could be 10 foot. They could be 1 millimeter. It depends on what scale the issue is. If you're looking at maps of the Rocky Mountains, they'll often have them in 25 or 50 foot contours because the scale changes so quickly. But generally on the exam, it's probably going to be a 1 foot contour, but you should always check to make sure. So let's say these are sort of 1 foot elevation differences. And so if we drew those across the land, which happens to be sort of dead straight angle, which is a little unusual, but we're just going to go with it. We'd have that nice rhythm of contour lines. And so if we looked at that down in a plan form, that's just going to be a bunch of straight lines. I'm not sure if I'm going to get the exact right number, but you get the idea. So that's pretty straightforward. If I was going to dig a ditch on here, and that ditch is going to start to make an impact on that, well, each of those lines is no longer going to be a straight line, right? Each of those lines is now going to start doing, I have to do it a little differently here. I'll do it right over on this one. Each of those lines is going to start looking like that. And one of the things that people make the mistake on all the time is they start pointing the wrong direction for the swale. If you point the wrong direction, you're not making a ditch, you're making a berm, you're making a mound. And so you have to just get really used to this as an idea. I know that sounds, like I said, a little simplistic, but like I said, this is one of those things that people tell me all the time they make a mistake on. And there's no reason that you should make that mistake. So you can see very quickly that the swale, if you're talking about cutting into the land, the swale is pointing uphill. that make sense? So that's how I always say it. I always think of it as the swale is reaching up the hill to grab the water. That's sort of a ridiculous thing to say. Find the system that works for you so that you work fast and you don't have to think about it. You should just know how to make that work. So think about it. For the people who are in the room, I always just, when I'm thinking about this, I literally wave my hands around and I start saying, okay, it's a slope like this. I'm digging it out. Therefore, the line is going like that, and I never make a mistake. So just find the system that works for you for how you can remember that. But you absolutely want to be very clear because you will not pass the exam if you get that one backwards. So that's pretty simple and straightforward. You can maneuver water through a berm, a mound, but 95% of the time you're going to be doing it through a swale. So you're going to be making ditches that specifically function as a way to gather the water, right? So why does a swale work? Well, the swale works because the water is going to always find the lowest, closest slope, like the way to get down fastest. It's using gravity. It's going to find the way to get down fastest. So any water that's anywhere near that is going to find its way to the swale, and it's going to start to be a gathering point. It's essentially how creeks work and all that. They eventually continue to be a gathering point and eventually become rivers, eventually become big rivers. That idea works at all different scales, both at kind of the river scale, but also at just kind of a simple site planning scale. So you can very easily imagine that if you were working on something and it had a bunch of lines like that, and you were trying to protect something that was, say, there, I could start to change that. Man, it's driving me crazy. Hang on. I could start to change that in such a way that I would catch it so that in this case, as the water is coming down, it's going to go straight into our structure. In this case, water that's coming down is going to get caught by that swale and go right around our structure. That's what you're doing on this vignette. That's the entire thing of it. It isn't any more complicated than that. There's a couple little tricks about how to do it. You have to be a little careful about how the buttons work. If you're out in the world, generally these swales look kind of roundy. You can see I always sketch it roundy because I'm old school and used to drawing them. And that's sort of how they are sort of generally perceived, and that's how they should look. On the exam, they're done with the lines are made up of they're connected little buttons, and you move one of the buttons, and as you move a button, it changes it and it becomes much more. So it might be something like that, and you move that button, and now this line goes from there to there instead. So it's more pointy and more triangle-y looking than what most people do out in the world. Doesn't really matter. It's not a meaningful difference. It just note that when you look at drawings, they may not have the same kind of quality look as the way this particular vignette works. It's just a way to keep it simple and easy for the computer and you during the process. Couple of things about that, though. Be careful if, let's say there's a property line or a tree line or something that's there, and you're moving this button and you're moving that over, it's very easy to accidentally not realize that you've actually changed something that you don't have control of, or you shouldn't be messing around underneath the trees. So be careful about the buttons. It's one of those little tricky things you got to work out. You can put in more buttons, but you can't get rid of buttons, so it's a little funny. So this is one that you definitely want to spend some time practicing on. And then just to kind of make the point, there's a few obvious things about this. If we do that same idea on this particular example and we bring those lines across in our set contour, very quickly you realize that the spacing of the contours is actually quite telling, that the closer they are together, so the tight ones, that's showing the steep space, and the ones that are farther apart from each other, that's talking about the lower slope. So it's just very fast. It's like in 2Ds, you can actually understand three-dimensional space really shockingly well. It's amazing how fast you can understand 3D and 2D for using this simple system. One other quick thing to say about it, the contours are just a useful way of understanding the lay of the land. They are not meaningful other than that. There is nothing sacred. When you see a contour line, it doesn't exist in the world. It's a made up concept. It's an abstract idea. You'll find people often start lining up sidewalks with contours, or putting the building against the contour line, because it just seems like it's a line. It should be meaningful. It's meaningful in terms of the lay of the land, in terms of the shape of the land, but it's not meaningful for any other reason. If you imagine that, let's say, due to global warming, the average high water mark changed by 4 inches. And so we recalculated all the contours, everything would shift 4 inches. It would still be meaningful to the lay of the land, but all the contours would be different, right? So it's an abstract way of thinking about these things. So when you're thinking about this and you're trying to figure out, well, how far apart should these things be in terms of those numbers that I was just talking about, you can, while you're working on the program, you can use circles. Let's say I have let's say we're trying to make sure that something is not steeper than 20% slope. So then if I use a circle that represents 20 over 100, which would be 1 over 5, so I use a 5-foot circle. That 5-foot circle will give me a sense that these things are either too close or too far apart. I can tell very quickly and easily, and I can move circles and make circles very simply and easily. That's one of the things you'll often use on this as a way, sort of as a measuring tool. All right, so that's pretty fast, but I think gives you a kind of a sense of what's expected of you. As I said, it's really about making the water, controlling how the water moves across the site, without trying to dramatically change the overall pattern of how the water moves. If the water is moving from left to right and there's something in the middle you're trying to protect, you're not going to be able to get the water to move from right to left. It's too hard. It's too many things. Like you're going against nature. It's not reasonable. So you're always working with the issue at hand, working with the way the water is trying to flow on the site, and just trying to get it to not do the damaging things and go around. Don't be worried about being dramatic. Those pointy swales are okay. The biggest worry you have to have is that there are limitations on what the slopes can be, and you can't let the contours get too close to each other or too far apart from each other. Then you'll be with the wrong slope, like we said. All right, let's move on to the next vignette. This one is site design. Here's an example one from a while ago that they used. The site design vignette is, I find, terribly annoying. I find this one annoying in the way that I find the interior layout annoying on the schematic design exam. Everybody, when they take the schematic design exam, worries about the big building design, because you have to do a 2-story building and it's a lot of rooms and there's all these huge program and everything. But you actually have tons of time for that one. And yeah, it's a big program, but it's essentially a pretty simple thing you have to pull together. The interior layout seems like it should be dead simple. Like everybody in this room, I'm sure everybody online has done a small office layout before. Like how hard could that be? But you have to do it really fast. And so people make just sort of dumb mistakes about kind of moving through. Well, this is kind of the same thing. You're not really doing an in-depth site design. You're just sort of worried about a couple of specific issues, and you're going to think about like some orientation issues. You're going to think about how the drives work, and maybe some sightline issues, and how the wind flows across the site, a few other things like that. But nothing particularly dramatic. This is not a complicated. This is not a complicated thing, but there's a lot of little unusual details in it. There's like, well, this should be near that. Well, how much time are you going to spend thinking about what near means? Is near 10 feet? Is it a third of the sight line? Like, what does it mean? So there's a lot of words and there's a lot of process on this one that are just sort of odd and a little confusing. So this one is definitely one of those ones that you want to make sure you practice. All of them you should definitely practice. The vignettes are all about being comfortable with the program, so you really know exactly you're not worried about how you do things. You're only worried about what the program is asking you to do and how you're going to move forward with it. So you definitely want to spend some time practicing with it and getting used to how you move things around and how you make quick decisions. So again, this is going to be one where there's going to be certain things that are given on this particular example. There's two main streets that are shown. There's the site boundaries shown. There's a site setback that's been given. So that's the building setback. In this case, there's a bunch of trees and some ponds and maybe it might be like a rock outcrop someplace, something like that. And then also in this particular one, there's an easement. There's likely to be something like a pond or an easement or both, something like that just sort of throws everything off a little bit and you have to kind of deal with, right? It might be an existing sculpture that you have to stay 20 feet away from, or it might be, an historical grouping of trees that have a special significance, and so you have to stay away from and not damage them. But it's likely to be something like an easement or a pond or something simple like that, and you have to sort of stay away and be careful of. And then in your tool list, you're going to have a bunch of things you have to place onto the site. So on this particular one, you've got a couple buildings you have to place, you have the driveway you have to place, and a parking lot that you had to place. And some walkways. When you're doing that, you're trying to follow all those rules. You're trying to, it says don't go anywhere near the pond. It has a specific distance. So you're trying not to go near the pond. You're making sure you're not crossing the easement because the easement has a sort of a sacred aspect to it. You can't just start throwing things across the easement. And then there's a bunch of other little rules about which way things are facing, what gets sunlight, what doesn't get sunlight, all of those kinds of issues. And you're sort of placing those things around a bunch of existing trees. So there's sort of this odd quality to it because you're kind of placing and moving these things, but you have to kind of imagine that you're just trying to fit into where all these trees are, and then you're allowed to sort of kill off a few trees. I would always read to make sure what number it is. I think it's typically 6. It could be wrong. It might be 5. I can't remember. I haven't looked at it recently. But whatever it is, I would always think of it as one less than that, because you can often get into a situation where you're sort of moving along. You think you've got everything answered. There's like a minute and a half left, and you realize, oh my God, I never put the sidewalk out to connect to the patio. And you got to throw one in, and the only place to do it, there's a tree in the way. You just want to give yourself a little bit of breathing room for that last second. That's going to make a big difference as you're doing those things. So let's kind of quickly kind of run through. I have a sort of a list of a couple simple things. One is logical organization. Another is rules of thumb, simple orientation aspects, drive and parking. And then one kind of key one is, like all the vignettes, it does not have to be beautiful. In fact, if you are thinking about anything along the lines of beautiful, you should probably just get up and walk out. This is not an exam that cares about beautiful. No aspect of this exam cares about beautiful. It is only about competent and answering the program that you've been asked to answer. Even to the point that there will be sometimes things that you're asked to do that don't meet accessibility codes or don't meet some other code. If it's not in the vignette, you don't have to follow it. It's only what they tell you in that aspect. Mostly the vignettes are puzzles with rules, and you have to answer the puzzle. That's the main thing about them. So let's run through some of these issues and think about how these can be talked about. So, logical organization. So the first thing I would say is, like any of the vignettes, you should have a system for taking notes. So what does that mean? I mean, like the way I would do it is I would, on my scratch paper, as soon as I walked in, I'd turn the computer on and the thing is going, I would quickly make a little matrix and I would start putting information from the program into my matrix, square footages or distances or important key elements, like this should have a view of that or whatever it is. This is one of the things you practice when you practice on the program. You're not just practicing using the program, you're practicing how you take notes, how you think about the notes. Everybody's going to have a different way of doing it. Not everybody is going to agree that you have to write out notes. I personally think it's smart. I think for most people it's a good idea. I personally find it when you toggle back and forth between the program and the drawing page, that it sort of throws you off. Like it's hard to reorient yourself back into the drawing page when you do that, and find your note spot that you're looking for on the other. So if you're very comfortable with that, if you practice it and you realize, it just takes too long for me to write anything out, well, then don't write anything out. Find the way that works for you, but have a system for how you're going to deal with all the information. It's a key aspect to kind of how you do this. It's one of those things that sounds sort of obvious to say, but if nobody said it to you, you probably wouldn't think of it that way. You really, each different vignette will have a different system for your note taking, because there's different kinds of information that you're going to be keeping control of. Once you've sort of taken your notes, go through the entire program, take all the notes. Actually, the very first thing I would do is I'd look at the site that they give you, just so you have that in your head as you're reading through. But so you look at the site, read the notes, read the program, take your notes, and then first thing I would do after that is I'd very fast, very small thumbnail, do 2-3 different quick sketches. Excuse me. 2 or 3 different quick sketches that show some different possibilities about how you might attack this as a problem. So you've got a couple of ideas about how that can work. Don't spend very much time on it at all. Just do it as fast as you reasonably can. Then, once you have done a couple, you choose the one that you think is the most promising. You go into sketch mode. You start putting some green lines, which are the ones that don't count. The computer won't look at them. They're only for you. And do some very quick, but to scale, understanding, like, will this fit if I do it this way? Do I have enough room to fit the building? Do I have enough room to put a parking lot into this spot? And then, once you've done that, go back to your notes and read your notes again and make sure that you haven't forgotten anything. It's a lot of little details that can show up, like, the front door of the restaurant needs to be in sunlight during the day, something like that. Well, once you start putting it out on the plan, you can see that very quickly and easily. So it's an easy question, but it's easy to get lost if you don't go back and force yourself to do that. And you just won't know until you test it out on the site. You won't know if your sketch was correct. Once you've sort of gone through that, that shouldn't take very long. That's very, very fast. We're talking about just like quick ideas and then quick sketch lines. Go back to the notes, make sure that you haven't forgotten anything, and then just dive in and start doing it. The reason that you go through that process is that if you start putting things in and then down the road realize it's not going to work, it's very disconcerting if you're 40 minutes in and now you're like erasing everything and starting from scratch. You want to have that moment early with a sketch, not deep in with all the actual pieces in the actual vignette. So logical organization. Couple rules of thumb. One is about trees. If you see a deciduous tree, that's about shade. If you see a coniferous tree, it's about blocking wind or blocking view. It's just one of those things. So you place deciduous trees where you want shade. You place coniferous trees where you want to block wind or views. That can get a little more complicated. You start getting into it, but essentially, if it says block the wind for the patio, you put a few trees over there. Don't put a deciduous tree because that will fail you. When you're measuring, think about what you're going to measure with. Like I said on the previous vignette, circles is sort of a classic example. You can use circles very quickly and easily to see distances. It's an easy tool. But if you're talking about for driveways, it may be better to use rectangles, right? So find the tool that works for you. Sometimes people will use rectangles only to the center line of where they think the driveway wants to go. So one edge is actually the center line. If you start using the program a little bit, you'll find the way that works for you, but look for those as issues. Like find a system that works. It's not always going to be circles. It's not always going to be rectangles. So you may have noticed on the example that I showed a second ago around the pond, there were a whole bunch of circles. that was somebody testing to make sure that on an unusual shape, like a pond has an unusual pattern to it, and so it's hard to do a measuring tool. But if you put a bunch of circles next to it, it's very quick and easy to say if it's a 20-foot setback from the pond, and there's a 20-foot circle there, you can quickly see that it meets or doesn't meet it, in that. So you're looking for those kind of fast-paced ways of thinking about it. Every once in a while, you're actually going to measure stuff, but pretty rare. Most of the time, you're just kind of using those other things. And another piece here is, if you already are sure, if it's obvious that something meets the right, don't spend time measuring it. Don't put a bunch of circles next to a pond for the sake of measuring it if you already know that you're like put one in. If everything's obviously clear of it, don't spend time putting 5 more in. I've seen people talk to me about, I haven't seen them, but people talk to me about how they realized that they'd put in like 100 circles around something like a pond. Like, why? Like they don't, it's there for you. It's not there for anybody else. So if once you feel comfortable, stop and move on to the next thing. Time is of the essence. Follow the rules, don't do anything extra. You think, wow, it'd be really great if I put these coniferous trees in here to block the wind, but wouldn't it be nice if we filled that whole area with trees? And wouldn't it be nice that, like, that's getting into beautiful? Don't do that. The more you do that's extra and beyond, the more likely you're going to do something that actually causes you trouble in some way that you didn't realize. There's going to be a tree that is too close to a roadway, or there's going to be some. It's going to look inefficient. It's not going to make any sense. Okay. Next one, orientation. So orientation issues can be quite interesting and complicated, but what they do on this particular vignette is actually very simple. If you imagine if this is a little site plan with a building on it, and over on the east side, the sun is rising, I'm going to get a shadow that's going to obviously go off towards the left. At sunset over here, I'm going to get a shadow that's going to go off towards the right. But they're not going to ask you about that. What they're going to say is, okay, at noon or 1 or some sort of straightforward thing, I'm going to have a sun there, and that sun is going to come right there, and I'm going to cast a shadow right behind this. It might be a little bit off, but you'll see. So that's my shadow right there. Well, how long of a shadow is that? Well, the presumption is always going to be that that is a 45-degree angle. Sorry about the bad angle there. And so therefore, that distance is equal to the height of the building. Why is this important? Because there's bound to be something where it says this entrance can't be in shade, or this patio shouldn't be in shade, or something. It's going to be one thing that you're going to have to measure. Not going to be complicated, but you're going to have to know that in order to be able to answer that one set of issues. It's always going to be that 45-degree angle. It's always going to be noon. But read it to make sure, in case they change that, right? You never know. A couple quick things about parking and drives. There's going to be a couple different parking space sizes that will show up. Sometimes it might be as small as 18 by 8'6". I don't think it'll go down to 8 foot, but might. 19 by 9, I just sort of use as kind of a generic. It'll get you in the ballpark no matter what. The center line versus rectangles there, by the way, is about what I talked about earlier about being able to draw the driveways. Find the system that works for you, whether you're thinking about it as center lines or rectangles. Very nicely, the driveways heal themselves. So you just do a couple different angles and all the curves get done in for you. Back in my day, we had to do that with circle templates and all kinds of crazy things. But so, okay, if I have a parking space that's 19 by 9 or 9 by 19, and something says you need 20 cars, well, how big is the parking lot? Well, that may sound sort of like, oh my God, how big is the parking lot? It's actually dead simple, right? If I have 20 cars, I split that in half, so I have 10 and 10, and the space is going to be 19, and I'm going to have 19 on the other end, and then I've got a, say, 24-foot drive aisle. That means that this thing is 62 feet wide. So if you're drawing it at 60 feet wide or 64 feet wide, something in that range, you're going to be fine. But if you're drawing it at 50 feet wide or 42 feet wide, that's not going to work. And the computer will understand that that's not a reasonable amount of space for two lines of parking. And then how long is it the other way? Well, if I have 10 and they're each 9, that means this thing is 90 feet. And I've got 10 spaces, right? So you can do that in a couple seconds and know that 20 parking spaces, the sort of classic simple shape box that I'm looking for is something that is, in this case, 62 by 90, right? And you can draw that in sketch mode and see if it fits right off the bat. So this is one of those things. Know your numbers. Feel comfortable with how you move through those things to make that work. Man, if you can make something like that, that's awesome. You don't have to show all that stuff usually, but this is the ideal of what you're talking about. So that somebody comes in, and as they come in, they can go straight. They don't. If you come in at a point like this, then you have to make a decision which way you go, and people stop, and other people hit them from behind. Right? You want it to be a nice free flow in. There's the simple box. So there's my 62. My 62 for this one is right there, and then I've got another one right there. I have flow through, so I never have anybody backing up or getting in the way of other parking. I can easily get right around and then come back if I need to if a parking space is opened up. In this case, I have handicap spaces over here right next to the building, so they have direct access without having to cross one of the drive aisles. You always want the handicap spaces to be in a situation where they don't have to cross a drive aisle. Something like that is perfect. That's what you're shooting for. You're not going to be able to do it, right? I mean, it's going to be that, but there's going to be something in the way. There's going to be a tree right there that you have to save or something like that. Well, okay, so then you have to make it a little bigger and you have to go around the tree, whatever it is. But that's the kind of thing that you're trying to think about. When you're doing a quick sketch line, that's the thing you're thinking about. One other thing about driveways. Let's say this is our site plan, and I have two streets, a big street and a smaller street, and you find this great spot to be able to put the driveway right there, and it's say 20 feet off the corner. That will not work. You always want to move the driveway typically at least 100 or 120 feet, depending on the different codes, away from a corner. And the reason for that is people from here will drive and think they're turning down the street, but in fact will be turning into your driveway. They'll stop, they'll back up out into the street and cause an accident. So you don't want to get anything near the corner because it confuses people. So the driveways will almost always be held back some specific distance. Now, one of the things that will always happen when I say that is everybody starts thinking about all the example driveways they can think of that are closer than that to a corner. There are thousands and thousands and thousands of them that don't meet that rule. But that's because, like, if you have a 50-foot lot, you can't be 120 feet away from the corner, right? There's a whole bunch of reasons why that doesn't always make the case. Or if you're a gas station or a drive-through bank or something, there's reasons why that stuff works. But those are typically in situations that are very, very clear what's going on. In something like this, at night, you have a big piece of land and there's a fairly large driveway, two-way driveway that's 25 feet wide. People will mistake that all the time. This is one of those little rules. Another rule is always be careful about the site triangles. They used to think about site triangles. I don't know if they still do, but it's just sort of a good rule. So if I have a driveway coming down to a road, the last sort of distance I leave free and clear. I can have a deciduous tree there, but I can't have a coniferous tree, or I can't have a sign or something. And that means that somebody who's parked there getting ready to pull out into the street can see oncoming cars. How big is the triangle? Depends on how fast the street is. If this is a small neighborhood street, the triangle is pretty small. It's probably maybe 6-7 feet, something like that. If it's a very major street with like arterial, then I maybe have it as something much bigger triangle, because I need to see cars going 30, 40 miles an hour. Another quick thing about driveways. Let's say I have a situation where I'm coming down and there's a tree that I don't want to hit, and so I'm going to come across and I'm going to come out at an angle. Do not have the driveway hit the road at an angle. It always hits perpendicular. Do whatever you can maneuver around any tree you want, but once you get to that moment, make sure that that it actually is coming down to the street in that direct perpendicular way. Let's talk about some general site questions. Just leave the vignettes behind for a bit. I'm going to talk about a couple different things. One is understand the site. Another is understand the climate. Another is the regulatory environment. And then the last one is just kind of a little more in depth about thinking about soils and foundations. So there's a lot to say about this stuff, and we're only going to just touch the surface. But I think you start getting the idea. First thing, surveys. I'm trying to understand the site. Survey is going to be one of those things that I'm going to use to understand the site. Do I order the survey? The answer is no. Why do I not order the survey? Because contractually, it's the owner's responsibility. The owner is going to give you the site. That means they give you the survey. That means they give you the geotechnical report. That means they give you the environmental report. They also give you a program and a couple of other things. That's part of the contract. So somebody else hands that to you. It's kind of a key important sort of liability issue that the survey is done by others. And that's one of those things that shows up on a couple of different exams. And it's possible that it would show up here. So who does it? The owner hires that. When you talk about surveys, how do they measure in a survey? Decimal feet. That site plans are architectural, and they're done in architectural measurements. Surveys are engineering, and they're done in decimal feet. You sometimes see them in other measurement systems, but almost always it's decimal feet. The idea of benchmarked is that if I have a survey, it actually, the way that surveyors do it, they don't go back to the high water mark, somewhere in an ocean to figure out a survey in Tulsa. They're going to benchmark off of something that's already known. So everything is in relationship to something else. And you'll find that that's how surveys generally work. They're always about describing what this is in relationship to somewhere else. Survey is a legal document. It looks different than architectural drawings because it is different. It is a legal document. It's a different kind of thing that's useful to you, but it's not of your sort of general world. Topography, kind of understanding the site, that's something we just talked about it in the vignette, so I don't think I need to go into it. But that's something, obviously, is a huge part of understanding how the site's going to work. What that really means is, where does the water go? So like I said before, you do not want to get into a situation where you're making a proposal that says the water was coming down and draining off to the west, and now we're going to propose that it goes to the east. That's just not believable. It's not doable. And will cause all sorts of problems. You can imagine lots of kinds of questions that could ask that, right? It's sort of how do you deal with a situation where that kind of thing happens? So that's you just want to make sure that you're answering it in that way. Special features is just you'll often find in the questions they'll sort of give you a bunch of information, and then all of it will be red herrings because there's some special aspect to the site. So just parse the questions closely, so you know that you're not wasting time doing calculations or something else if it turns out there's no way to put a parking lot into that spot or whatever it happens to be. So special features is sort of a kind of concept that shows up a lot. Utilities. One of the things you'll find is when you're talking about site plans and surveys that it feels like there's a lot of flexibility about where, I have a site plan, I can put the house anywhere, I can put the building anywhere. Well, probably not. I'm probably going to really have to think about how the utilities are going to play into this. If I have two streets, where is the sewer system? Am I using a septic system? Well, if I'm going to use a septic system and I start thinking about that, and the only place to do that is in a higher elevation than where I want to put the structure, then that septic system is going to leach right into my basement. Well, that's no good, right? So understanding the utilities is, in fact, understanding site planning. Right? It's a huge part of it. You cannot forget those. It's easy to imagine questions that could show up about utilities. Soils, as I mentioned, when the owner signs a contract with you, not only are they giving you the survey, but they're also giving you the geotechnical report. So geotechnical is anytime somebody's going onto the site, either digging a big hole and doing a visual inspection, or doing a boring where they auger down, and sometimes it's called a split spoon, where they'll take this sort of tube, they'll push that down in, pull it out, open up the tube, and take a look at what the soil looks like. And from that, often just as a visual thing, but also just they can test it as well, but usually it's done visually, they will say, all right, this part is sandy soil with a little bit of clay in it. This is it's okay soil. Maybe you can get 2,000 PSF off that, pounds per square foot. So the geotechnical report is where you're going to find all that information. Can you think about what else you'll find there? Well, water table height you'll find. The capacity of each of the different soil types, where the soil types start. Does the sandy soil stop at 5 feet below grade, and then it becomes a combination of gravel and sand? And then down maybe at 15 feet, it becomes bedrock or something like that. But each one of those will have a different capacity, different pounds per square foot capacity they can respond to. And that's something you definitely want to know about and be able to analyze. If you've never spent any time with a geotechnical report, with a soil boring report, before you take the exam, I would definitely find one. You probably have one in an office you're working at, but you can also just find an example one online and just spend some time going through it. And do what you can to sort of understand that. And then environmental concerns, there's two different aspects to the environmental concerns. I'm not really going to talk about environmental stuff right now, but it's important to know that this is sort of understanding that. Again, if you have toxins on the site, that report is going to start to, environmental report that the owner gives you is going to tell you quite a bit of information about what's on the site. You're not part of that. You're just reading the report and responding to the recommendations. The reason for that is for liability things. But the other environmental issue that shows up when you're sort of understanding the site is, what are the opportunities? How does the orientation work? Are there things that I can do here? Do I have a really solid wind pattern that I can get energy from? Like, what are the other opportunities? Those are all kinds of things that you can imagine questions coming on about how to move forward. Okay, understanding the climate. So this is fairly straightforward. It gets very, very intense very quickly. I'm just going to touch on it just to remind you of a couple of specific issues. One is when somebody's talking about climate, anything like rain, snow, sun, wind, anything like that, you can break that down into two basic ideas. One is the micro and one is the macro. So the macro climate is the big picture. What's happening regionally? So I can talk about how much rain we get here in Chicago, or how much we get in Tucson, or how much we get in Seattle. And those are things I can look up, and we can find out. We can say, all right, in this region, the annual rainfall is roughly this. That might be useful to know. Do I need to put covers on the patio spaces? Do I need to have really big gutters, or can I go with small gutters? There's a lot of design decisions that start becoming important about kind of understanding that. Snow, am I worried about snow accumulation and structure and how that works? I can look that up in very clear ways. The idea of microclimate, though, is, well, that's great. I can look up that about wind, about snow, about sun, and have that sort of general information. But at the micro level, meaning on the site, we might be able to talk about a certain number of solar hours that you get if you're building a building in Indianapolis. That Indianapolis across the span of a year will get X number of 1,000 hours of sunlight averaged every year. You can find that number and know that how that's generally going to work. That's a very useful thing, but it's not useful at all if there's a tall building next to you that's shading the site all the time. That's a microclimate issue. So there's certain things I can learn from the macroclimate, and there's certain things I have to look at from the microclimate. If I'm putting up a wind turbine to generate electricity, I would definitely want to understand what the macroclimate wind directions are. So, like, is this a place where I have a consistent wind in a consistent direction? That's great. But if I put that then in an urban setting where there's a lot of turbulence because there's a lot of buildings, it's going to be meaningless. It's not going to work. I'm going to have to use a different kind of turbine that isn't monodirectional, right? So both of those issues, micro and macro, very important. You should definitely understand those things. Regulatory environment. If you haven't spent a lot of time doing code searches, this is one of those things. There's a number of books out there. There's some Cheng books that are really great on this, very simple to read. There's a number of other sort of textbook type things that are very useful for understanding these. But a few things you should absolutely understand. One of them is that within the sort of regulatory environment, the key one from a site planning standpoint is going to be the zoning code. There's going to be a bunch of other codes. The building code will have an impact. For example, I may not be able to build a building within a few feet of the property line because of worry about fire jumping from one property to another or something like that. That's the kind of thing that would show up in the building code. But generally, the site planning conditions that you're worried about are zoning code. So things like FAR. Now, not everywhere in the country uses the term FAR, but I do believe they use it on the exam. I've seen it in a couple of practice exams. FAR is floor area ratio. That's a way of understanding massing. It's a ratio of footage of the building compared to footage of the site. And it's very typical. If it's not FAR, there's some other way that they do the exact same thing in any code, zoning code across the country. So understanding massing is a big deal. You don't want giant buildings right next to little tiny buildings, usually, unless you're Houston. They seem to be okay with it. Permitted uses is sort of a concept that you'll find across the country. So the idea that if I have a residential district, it doesn't mean that I can only put residences in there. I can also put maybe a small stores or churches or a whole bunch of other things. It's a whole bunch of permitted uses in any given residential or, excuse me, any given zoning district. Setbacks, definitely something that will show up and you'll have to sort of think about some way on this exam. The idea that setbacks are there. So I have front setbacks, I have side setbacks, I have rear setbacks, and those are, the property is the property, but I can't necessarily build straight up to it. So one key question here is if I have let's say a rear setback of 40 feet, that means I can't build anything in that rear last 40 feet of a site. I say that, and yet anybody in Chicago knows, well, that's not true. There's garages and all kinds of things in the last 40 feet. A setback has a definition. It's not, there are different types of buildings. There are primary buildings, and then there are secondary buildings. So you have to kind of understand those things in order to understand how the setbacks work. Some things can be within a setback, some things can't. The idea of amendments and variances, this is also something that shows up a lot, and that's just, there are often times when what you want to do just doesn't fit into the zoning code. Well, sometimes that's just too bad. You just can't build it. And sometimes you can find a way to amend the code or get a variance, an allowance to do something altering. They probably won't get too deep into any of the specifics of the differences between amendments and variances because they're actually, I think, a little different in different jurisdictions. But amendments tend to be bigger issues. Variances tend to be smaller issues. Allowances tend to be sort of easier ones right across the desk. The other codes, like I said, building codes, but there's also a whole series of overlay issues. So things like historical districts, right? You may be in a certain district that has a certain set of zoning, but there may be a whole second set of issues you have to follow that aren't in the zoning code, but there are other issues that you have to still follow. Like maybe you can't build in front of an historical building or something that you can't block the site of it or you can't change the shape of it, something along those lines. FAA is an interesting one. If you're building near airport, you have to you following the zoning code, but you still can't build a tall building near an airport, right? Because the plane's going to hit it. There's watershed issues, a whole bunch of other ones. And then there's a different type of overlay, and this one is kind of new on the horizon in the last 10, 15 years. People started talking about it a lot, and I hear that it's starting to show up onto the exam. And this is an overlay of things like it's possible to have say a zoning code that says, all right, given this site, this size, in this situation, this district, let's say you can do 20 apartments. But if you're going to make them 50% of them be affordable at a very specific legal understanding of what affordable means, then you get 2 extra apartments. That's an overlay zoning where there's a set zone, a set bunch of rules and regulations, but then there are other issues that allow you to do other things. Another one that people in urban settings often will understand is I can do sometimes a taller building if I give a plaza as an amenity to the city, right? That's an overlay zone, right? So there's a set zone, but that's not the only issue. You have to sort of understand there's multiple issues. Covenants and easements also show up a lot because they're sort of odd. A covenant is essentially a zoning code that's private. So like if I have a gated community or something like that, there's probably a bunch of rules about how you can build your house. It has to have peaked roofs, or it has to be cedar sided or something. Like there's these rules that are specific, and it's to create a sense of continuity. You have to follow those because they're legal to the deed, but they are not legal to the city. The city doesn't care. The municipality doesn't care. That's a covenant that's legal to the deed. So it's a private legal contract that you've signed by buying into that particular development. Easements are kind of similar. Easements are contracts that ride with the deed. So if I have a utility easement or something, I have a driveway easement for somebody, that's something that rides with the deed. So it's a legal construct, but it's not part of the zoning code, right? It's not a regulation. It's part of a contract that's on that site. I'm not going to say too much about this. This is something you should really spend some time on. But foundations and soils, you should understand that they range all the way from organics, like peat and things like that, to bedrock, which could be anywhere from 8,000 PSF to 10 to 12,000. Sometimes you'll see even 15, 16,000 PSF, pounds per square foot capacity. If you see anything that has anything that looks like a word that says something like organic, the answer is no, you cannot put anything on it. That's a very easy question to ask. They'll say, all right, we've got all this stuff, and here's the peat, and here's the this and that, and how much of a load can we put on it? And the answer is none. You'd never put anything on anything organic. The reason for that is that it will change over time, it'll decompose, and your building will shift and sway. So you always dig under, get rid of the organics, and get down to something useful. The something useful is going to be something along the lines of sand, silt, and gravel, and clay. It's almost never all of one thing. Sometimes it is, but almost never. Usually it'll say clayey sand or sandy clay or gravelly clay sand or something like that. It's some funny mix of those things. And there's all kinds of ranges that can be between. Sort of the lowest range that you can really build on, I usually say, is about 1,500 PSF. Sometimes you'll see it written out as 1,000 PSF. 1,000 seems pretty low to me, but 1,500 is pretty typical as a minimum. 3,000, if you got 3,000, you can put a pretty reasonable building on it. If you have something that's super heavy structure or big, you're really going to be hoping for like 5,000 if you can. And if you you really would love to get to that bedrock and get down to some really serious capacity. But then there's always this kind of balance question. And that balance question is, if I have a building and I'm trying to put in my little foundation here, and I'm only getting 1,500 at my typical foundation level, 1,500 PSF, I have to have a pretty massive foundation there in order to make that hold up a great big building. So maybe that's okay. Maybe I'm willing to spend the money on that foundation, or maybe instead I'm going to be willing to do something that reaches down with some caissons, say, and gets down to my bedrock, which has much, much higher. So is it cheaper and better to use these sort of columns of these caissons but get to some really serious capacity? Or is it just cheaper and better to have it be shallower, I don't have to dig down as far, and I have a big, massive strip? There's no easy way to answer that. That's a kind of thing you just have to be able to kind of answer on the fly, because it's going to depend on water table levels. It's going to depend on how big a load is it actually, all of those things. So you're looking in the question for what are they actually asking you, right? But sort of understand that's sort of one of the classic situations when you're doing site planning. You're trying to figure out how are we going to make the soils on this thing work. Foundations are mostly pretty obvious. Strip foundations, raft foundations. A raft is quite likely to show up because it's kind of unusual. A raft foundation is where the soils just suck. Like you just got really bad soils. You're not really sure about it. And so instead of worrying about it, what you're going to do is you're going to turn the entire basement floor into a foundation. And I'm just going to make a great big thick, maybe 2 feet thick concrete slab. I'm going to put a whole bunch of rebar in it. and it's just going to float on top of whatever the hell crappy soil you've got. And it's considered a raft, and it's literally floating on top of bad soil. It's pretty rare because 2 foot thick with a whole lot of rebar is very expensive for most structures. But there are certain situations, if it's that or going down 120 feet with caissons, you might choose the raft. Piles, you probably all heard of, like wood piles, steel piles, and then caissons. One thing that they often like to talk about is the belling out of caissons in order to make the bottom wider. They have these cool augers that flip out as it's spinning down and going into the ground, so that when you get down to the bottom, they make them wider. It makes that hole wider. And caissons, like I said in the last slide, caissons are essentially the idea of giant concrete columns that reach down to really good bearing capacity soil. You essentially completely ignore all that other soil. It's just like you're building a building on stilts, and there happens to be soil around the stilts. So it's a totally different way of thinking about it than the strip footings and that kind of thing. Last but not least, I think we'll get into questions for a few minutes. I stole this off of a Ballast book from many, many years ago, so apologies to Ballast. But I just love this example. So this is an example question from the site planning thing from their books from quite a while ago. You look at that image, and the question is, where does the restaurant go? How crazy is that, right? Is it number one? Well, no, right? Because number one is too high up. It's going to get all the wind. It's going to be all kinds of problems, right? Now, obviously, we don't really know that. We're only going off of what we know. But from what we know, this is what we would say. Is it going to be number three? What's the problem with number three? It's right in the drainage line, right? It's going to flood out all the time. It's definitely not three. So it's kind of between 4 and 2. And start thinking about it. Well, 4 looks pretty good. I got a pretty good view of the lake, but look at that. I got wind right there. This mound here is going to block that wind. It's going to protect my building. 2 still has a good view of the lake. It's outside of the drainage run. 2 is the answer. So how ridiculous is that? That's the kind of question you might get. But the thing to remember here is there's certain things you're bringing to the table because you know about architecture, but there's other things that are like you're just dealing with what's in the question. Don't make it more complicated. Don't try to make it fancier. You're using what's there and trying to answer that question. I wouldn't. So the question was, if you have an atypical shape on a building in the grading vignette, would you actually like bring the contours, like the swales or things, into the interior crevices? The answer is it depends. Typically, it's not really going to matter. Like what you're looking at generally is sort of big picture, right? If you think of the rain hitting the upper part of the site and flowing across the site, you're just trying to move it around the issues. So it's possible that you would want to have it touch into those kind of crevices, but probably not, right? You're trying to keep it as simple as you can, but still answer all the issues. You're going to find no matter what you do, there's going to be a little spot that's still going to drain, like, a 3 foot area that's going to drain onto your site. That's okay. That's not what they're talking about. What they're talking about is like a giant rainfall coming down on the site and the site next to you and all draining into your building or onto your foundation of a sculpture or whatever it is. So you're looking for big picture on it. So you don't need to get too minute, but you may need to answer it by getting into the crevice if that's the question that you have to answer, but probably not.
So Emily asks, is percent slope always vertical or horizontal, or can it be the other way, horizontal, vertical? Yeah, so if you're talking about percent slopes, the way to think of it is if it says a 20% slope, think of that as 20 vertical compared to 100 horizontal. So it's the percent, the 100 is always the horizontal, and that's the sort of baseline. And then you have to translate that into something useful for yourself. So 20% slope is 20 to 100 is the same as 1 to 5. Therefore, a 1 foot vertical contour, if it's 5 feet apart to the next one on the plan, then that means that's a 20% slope, right? So you can see it very quickly and easily, but it's always
that the 100 baseline is always the horizontal.
I will make a note here that we have a little link here to Mike's recommended a number of resources outside of just our online prep, so books that you should take a look at. So use that link. That's one of them.
Yeah,
any other?
And we'll actually be adding some more. I've been thinking about it a little bit. I'm going to be adding some more to that list. For this particular one, the one that I love, and I think is just a brilliant, easy book with very simple drawings on it, is called Sun, Wind, and what is it? Sun, Wind, and something.
This one here. Where is it?
Oh, damn.
Oh no, this one, Sun, Wind, and Light.
Sun, Wind, and Light. It's really a great book. There's a number of different versions of it. Any of the versions are fine. It has very, very simple graphics that are like super explanatory. I steal them all the time when I'm doing lectures. And it talks about orientation. It talks about wind patterns. It talks about shapes of buildings and how the shape of the building impacts the flow of the wind. So if you're trying to talk about like where should the patio go, you can start thinking about the shape of the roof, and it'll affect the location where you might put things. It's very simple and straightforward, and yet incredibly detailed. Beyond that, there's actually a number of very good books, but sort of they tend to be more kind of not big picture, more specific. There's a couple of really great ones, like Ian McHarg's Design with Nature, I think it's called. I actually met Ian McHarg when I was an undergrad back way years ago. He was an amazing, amazing guy. I can't really imagine you're going to read that book for this exam. It's more of just a really interesting book about designing with nature. The Sun, Wind, and Light is super helpful. So I think that's a great one. And there's lots of other examples. You find the Ching has a lot of very good stuff about site plans. There's a bunch of different sources. We'll probably put some more resources up on our link list as well.
All right, well, thanks, Mike. And thanks to all of you who've tuned in. If you'd like to attend our next ARE live broadcast, visit blackspectacles.com/podcast to register to attend. You'll have a chance to ask questions and share your answers with Mike for live feedback during that broadcast. And to learn more about our AIA ARE Prep Curriculum, go to blackspectacles.com. We'll also put a link in the show notes. And for those of you who want to get busy preparing for the ARE, you can use a 15% coupon off the first charge of any AIA ARE Prep membership with code 52715webinar, which will expire on June 15th. And of course, if you're already an AIA member, you can visit aia.org/ARE Prep to get a 30% discount for the entire duration of your AIA ARE Prep membership, not just the first charge. This also expires on June 15th. And finally, please leave a comment below the video to let us know what you think and share any suggestions you may have. I promise we'll read every word that you write and use them to tune our next episodes. So thanks for watching.